Hey, welcome to the last unit of the year. All right, we're in section 12.1, graphing quadratic equations. Let's start off with some definitions that'll make our lives a little bit easier. So a standard form of a quadratic function or quadratic equation, we're going to use those two words sort of, in unison. They mean the same thing for all intents and purposes. So standard form is just like when we worked with polynomials, but the only difference is that we have this f of x, and what that f of x means is just that we have a function with x as our variable, and we're going to have ax squared plus bx plus c. All right, the only stipulation that we have is that a cannot be 0 because we do need an x squared term for this to even be quadratic. But you don't have to have a bx term and you don't have to have a c term. But most of the ones that we'll work with today will have those. A parabola. Now the parabola is the shape of the graph of a quadratic function. And for all of our graphs today, they're going to follow a basic U shape. That's what a parabola looks like, is some sort of a U, whether it's wide or skinny or upwards or downwards. Okay, the idea here is that it's going to look like a U once we're done with it. So let's look at the next thing here, is called the vertex. And the vertex is the point where the graph changes directions. Okay. Since it's a U shape, it has to, it might start off coming down and then go up, or start off going up and then come down. That point of changing directions is called the vertex. We kind of think of the vertex as the middle of this graph, and I'll get to why that is a little bit later. But it's also considered the maximum or the minimum of the graph, depending on which way it opens. If it, if it goes upwards, then it's the minimum. If it goes downwards, then it's the maximum. Okay. And then the last thing that we have is called the axis of symmetry. And now what the axis of symmetry is it is a vertical line. It's a vertical line that goes through the vertex. And what it does is it creates a mirror image. So whatever you see on one side, you'll also see on the other. Now, let's go ahead and read through this little thing at the bottom. Or not the bottom, but the middle of the page that talks about the graph of a quadratic function. What it says is that we have, sorry about that. We have the graph of the quadratic function is a parabola, and if the a value is positive, it opens upwards, and if it's negative, it opens downwards. Okay, and the two looks for that will be, upwards would look like this, downwards looking like this. Okay, and then the vertex has an x-coordinate of negative b over 2a. And so let's say that we have the vertex here. The x-coordinate of that will be that negative b over 2a, using the a and b from up above. So whatever you have there is what it's going to be. Now, what we're going to use a lot of is called the axis of symmetry. And I'm going to put that in a different color. So if we're looking at this, the axis of symmetry is a vertical line that goes through the vertex, and the equation of that would be x equals negative b over 2a. All right. And so what we get is we're going to get a parabola. Say it comes out like this. All right, whatever you see on one side, you flip that over, and you get that same thing on the other side. And I'm going to show you how we use that here in a little bit. but that definitely is something that will make your life a lot easier. Okay, so let's start off with what's called the parent function. Now remember, I mentioned last time that you can do different things to different pieces of the graph to make it look a little bit different every single time. But we're going to deal with the most basic one that we can use, and that is f of x equals x squared. So in this, and something that usually helps people out, is to say that that's the same thing as 1x squared plus 0x plus c, plus 0. But what I'm getting at here is that here is my a, here is my b, and here is my c. Okay, and I'm going to use those three letters to figure out the different pieces of this graph. So let's go ahead and start out by finding the vertex. So the vertex, the x-coordinate is at negative b over 2a. So negative b, which would be negative 0, over 2 times 1. So we have 0 over 2, which is just going to simplify to 0. So my vertex is right here. I don't know what the y-coordinate is yet. I just figured out what the x-coordinate is. So here, obviously, we're using a table of values. And all I want to do really is plug in these numbers into this equation and see what I get. So what's negative 4 squared? Well, that's negative 4. So negative 4 times negative 4. Well, negative 4 times negative 4 is going to give me a positive 16. Okay, I'm going to go ahead and graph that over here. So at negative 4, it's all the way up at 16. So I get this point right here. Pay attention to the scale on this graph. It's sort of adjusted. Every square vertically is 1, but every square horizontally is 2. Okay, you can't see them as well in the video, but there is another square in between, 0 and negative 1. At negative 3, so what's negative 3 squared? Well, that's negative 3 times negative 3, which is 9. So at negative 3, it's 9. That's going to be right here. At negative 2 times negative 2 is 4, so we get 4. Negative 1 times negative 1 is positive 1, so we get that point right there. And at 0, 0 times 0 is 0, and so we get that point right there. Okay, and as I said, we have an axis of symmetry. It goes right through this vertical axis, the y-axis, and so the idea is whatever I got on one side of it, I would get on the other side. But let's fill in the table first. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So as you see, if I could almost fold this table in half and get the same numbers on the top as the bottom. Okay, so I get at 1 it's 1, at 2 it's 4, at 3 it's 9, and at 4 it's 16. So my graph looks a little bit, and again, we're dealing with a smooth curve, so don't just go straight there, turn straight there, turn straight there. Okay, don't do that. Try to make it as smooth as you can. And if you remember what I said in the graphing radicals section, there should be no sudden changes of direction. It should be a gradual change. And again, all I'm asking that you do is do it as well, or maybe even a little bit better than mine. Since I'm right-handed, the left side is always harder. And I'm totally missing those points. Missed them all on the bottom side. Okay, so make your graph a little bit. Sometimes I've found that it does help to kind of scratch out the line instead of try to make it one constant line. But just do your best, and like I said before, make sure you give me an effort. It doesn't have to be pretty, but as long as you're giving an effort, that shows me that you deserve it. So the idea of the axis of symmetry. In order to get from this point to the axis of symmetry, I moved 1 unit. So I move 1 unit the other way. Those two segments there are the same size. And that's true on every point here. So I go 2 units to get to the axis, 2 more units the other way. Okay, 2 units. Here I went 3 units, so I go 3 units. 1, 2, 3, 1, 2, 3. So all those segments are the same size, and whatever point in between those, it's true also. I feel like this is pretty close to like 2.5. Well, I'd go 2.5 to get the other one. Okay, and so that's really cool, and that works for the entire graph, and it works for every parabola that you're going to graph. So it's really neat, and it really helps you out. Let's see exactly how it's going to help us out with some examples. All right. Now, again, this is one of those pieces that I took right out of a book. Just copy pasted it in here. It is good to do. It's a good process to follow, but we're going to change it a little bit. All right. We should start off by finding the x-coordinate of the vertex, which also finds us the axis of symmetry. And whenever I'm writing axis of symmetry, I always shorten it by SYMM. It makes life a little bit easier. Then it says make a table of values using x values to the left and right of the vertex. I would just say to one side. Okay, to one side of the vertex. And then it says to plot the points and connect them with a smooth curve. But kind of a step 2b. So step 2b instead of just step 2 is to mirror the values. Mirror your values across the axis of symmetry. Okay, and so that's going to make our lives a little bit easier because we don't have to find as many points now. I can just find a few points and then mirror those across the axis of symmetry. So sort of, my steps, they're a little bit adjusted from here. Let's find the vertex, draw the axis of symmetry, plug in points on one side of the vertex, flip them over, and then connect that smooth curve. So let's see if we can do that. Let's start off by finding that x-coordinate of the vertex. So x equals negative b over 2a. That's kind of tough to remember, but by the time by the time it's all said and done, you'll have it pretty down because you're going to do it all the time. So negative b, I have an a there, b there, c there. So negative b is a negative 2 over 2 times 1. A is 1. Negative 2 is positive 2 over 2, which equals 1. So my x-coordinate of my vertex, or more importantly for right now, that my axis of symmetry is 1. I can't really plot the vertex right now because I don't know what the y value of the vertex is. So let's go ahead and find that. So the way that I start my table is I start with the vertex. The x-coordinate is 1. Let's find the y-coordinate. Well, it's equal to 1 squared minus 2 times 1 minus 3. 1 squared is 1. 2 times 1, so that's minus 2 minus 3. 1 minus 2 minus 3 is going to be negative 4. So we get that point all the way down here at negative 4. So you see why I didn't just plug in numbers, because I'm going to need a little bit of room to work this stuff out. And then I'm just going to plug in the next number. I think 2 is a good idea. Might as well give it a shot. So let's plug in 2. So I'm going to have 2 squared minus 2 times 2 minus 3. 2 squared is 4. 2 times 2 is 4 minus 3. 4 minus 4 is 0. Minus 3 is negative 3. So at 2 it's negative 3. And then we'll see what happens at 3. So I get 3 squared minus 2 times 3 minus 3. 3 squared is 9. 2 times 3 is 6. And minus 3, we get 0 out of that. All right, so at 3 it's 0. So that's one side of what my graph kind of looks like. I'm going to go ahead and mirror that over. So to get from here to the red line, I go 1 unit. So I go 1 unit the other way. And to get from here to the red line, sorry, let me put that point there. From here to the red line, I go 2. So I want to go 2 more units and plot my point. And so we get this smooth curve. Looks kind of like that. And a lot of times what I'll do is I'll try to go over kind of that first, that change of direction at the vertex, because it tends to look kind of V-ish when I do it the first time. Okay? I'm going to show you using a calculator how you can make your life a little bit easier for finding these values. Okay? But first off, on this next problem, I need to find my axis of symmetry, or my x-coordinate of my vertex. It's negative b, so x equals negative b over 2a. And that's going to be a negative 1 over 2 times negative 2. Negative 1 is positive 1. Negative 2 times 2 is negative 4. So we get negative 1/4. All right. My XY table, starting with negative 1/4. I'm going to try to put that on here, and it could be a little bit ugly because the scale on my graph makes it so. Okay, but that's about my axis of symmetry. Let's see how I can use the calculator to help me out. And so I would recommend grabbing one of these TI-30X2s or something equivalent to it, and I'll show you why. I'm going to put in my equation. All right, so I have negative 2, parentheses, negative 1, I'm going to use fractions here, squared, so negative 1/4 squared, minus, use parentheses again, 1/4, plus 2. And I get 1 and 5/8, is that right? I don't think I put in a negative. Yeah, so make sure that you do it right. All right, that's a negative 1/4 as my vertex. So I get 2 and 1/8. So 2 and 1/8. Even though I really like improper fractions, sometimes it does help to use mixed numbers because it's a little bit easier to see. Okay, that's where that point's going to be. All right. Now, here's why I like using these calculators. From here, I just want to hit the up arrow, and I can go back to that same equation, and I can change my numbers a little bit. So I'm going to pick, I don't want to pick 0 because it's really close to that line, to the axis. I'm going to pick 1, and, or no, I will pick 0. Yeah, we'll pick 0 and 1. So let's go 0 and 1. Okay. This problem is going to be really difficult because of the fact that our axis of symmetry was a fraction. So I'm still going to pick 0. So all I do is I go back in and replace the 1/4 with 0. And then I just hit enter again, and it gives me my answer, 2. So I have a 2. So at 0, this thing's 2. That's right there. See, but that's really close to that axis. And I'm probably not going to mirror on this one because it is an ugly answer there. Excuse me. But when we plug in 1, we should get something that feels a little bit better, that gives us a little more idea. At 1, it's -1. So at 1, it's -1. And so yeah, that's hard to mirror because you're going 1 unit and a fourth to get back to the axis. I'm just going to go ahead and plug in a couple more numbers since I already have it in my calculator. So I'm going to go kind of the way the definition up top here tells me to. I'm going to pick -1 and -2, and I'm going to put those into the calculator to figure out what they are. So I just go up. Since I already have a 1 there, I just need to insert. Crap, wrong button. I need to second insert a negative. And I'll do that here as well. And when I get that, when I hit enter on that, it tells me that the answer is 1. So at -1, it's 1. It's right there. And at -2, it's -4. This is definitely something that you could have done by hand and even just kind of talked yourself through, but it definitely makes life easier. And when you can use a calculator to help you, I always advise it. So now it's kind of different because I didn't use my mirror image, but I can kind of get a glimpse at what this is going to look like now. So trying to make a smooth curve, it's always the tough part. Smooth curve there, and smooth curve there. Okay, the right side suffered a little bit. Probably should have been a little bit wider, more like that. All right, and then again, try to go over and smooth out that transition at the vertex. And again, once you're showing me solid effort, I'm more than happy. All right, that one was a really tough problem. What I want you to do now is go ahead and pause the video and try the last two. Okay, try those. Use a calculator if you have to. Okay, welcome back. Hopefully you had a chance to get those done. Let's see what it looks like. To start off here, I want to find my x-coordinate of my vertex, or my axis of symmetry. -b over 2a. -4 over 2 times, -1. And so that's -4 over -2, which is 2. Thank goodness it landed at a decent point. Axis of symmetry right through there. So I'm going to start off by plugging in 2 into my equation. So I'm just going to put it into the calculator. -2 squared plus 4 times 2 minus 1. And I get 3. I'll plug in, sorry, at 2 it's 3. I'll go ahead and plug in, let's use 1 and 0. I like using 0 when I can. So I'll just go back through here and change the 2's to 1's. The reason I use parentheses on here is so that I see where the number I'm replacing is at. And also if it's a negative, you need to have parentheses. So at 1 it's 2. So at 1 it's 2, and at 0, so just go back through here, replace the 1's with 0's, and we get -1. So at 0 it's -1. And now I'll use my mirror image idea. It takes me 1 unit to get to the line, go 1 more unit horizontal, it takes me 2, go 2. Smooth curve. And it shouldn't really turn back in like that one did. It won't be turning back in. It'll continue to get wider and wider, just at a really slow rate. Sorry, at 0 it's -1. All right, last one and we'll be done here. X equals -b over 2a. -8 over 2 times 2 should give you a -2. See how I gave you guys the easy ones to do, and I took that hard one where it was a fraction? You're welcome. All right. Build my table of values, x, y, start with -2, and then I put it into a calculator. And let me get this to where you can see it a little bit. So 2 parentheses negative 2 squared plus 8 times negative 2 plus 4. So at negative 2, it's negative 4. So negative 2, it's at negative 4. And I'm going to plug in negative 1 and 0. If you get too far away from your vertex, your numbers are going to be really big and they probably won't fit on your graph. So that's why I advise against that. So let's replace the negative 2's with negative 1's. And I get negative 2. So negative 1, it's negative 2. And at 0, delete 0, delete 0, I get 4. See, so if I would have picked 1, it probably would have been way off the graph. Use my mirror image idea to give me my other 2 points. And this one's going to be tough because it's really steep. And good luck making that a nice seamless transition. It's a very sharp turn on that one. But good luck. If you guys have any questions, again, feel free to let me know, and I can help you out, whether you need help using your calculator, or if you just need to borrow one, make sure you come and talk to me. But anyways, good luck on the Practice Application and Mastery Challenge. We'll see you guys later. Alright, for the last set of after video entertainment, we're going to look at some baseball compilations and just some overall good plays that that I've found and put together for us. And so they're in no real order. We've done countdowns the whole time, but I just want us to kind of kick back and check out some really good plays from the baseball world. Since it is spring, we'll go with that baseball theme. The first set is going to be a set of web gems. Now what that means is probably a catch that shouldn't have been able to be made, but the player made it anyways. I hope you enjoy.
Reyes timed it perfectly and finishes off the... There's one, and how about Escobar? Reyes, you can do it. I can do it too. And I got you back.
At the line down toward center field. Crowd got a good jump on it. Leaps up and he got it. What a play by Mark. Jumps up. Serious hops and an unbelievable play. He's not watching it into the glove.
Rips that one into
1-2. He loops that to left field. Going to be a tough play. Jeter on the run, makes the play. And flies into the stand.
And that's sliced to left field, and it's another chance for Mitchell, and he makes a barehanded catch.
Take a left and maybe play again, probably. To right center field, Revere on the run, and he reaches out and he makes the catch. What a play by Ben Revere. Bruce was all the way around second base, and the double.
Winning run now at third. And a ball hit toward the middle. Diving catch by Brandon Phillips. He laid out to his right. Took the game-winning hit away from Wilson Ramos, sending this game to the 13th inning. You just talked about Phillips earlier when...
Ooh, a little broken bat, and... Oh, David Wright! What a play! Are you kidding? That may be the best I've ever seen.
That's a magnificent play by David Wright. Wow! What a play by David Wright! Do it again! Show it again!
And Matt Kemp hit the other one, that opposite field shot. There's a line drive to center by Gomez, and on comes Lagares, and he makes the catch on the second effort. What a play! I'm not sure I've ever seen the likes of this before. Trying to make the shoestring catch and then stumbling forward to grab it. An incredible play by Lagares.
We'll see plenty of this in the next 24 hours. Just shovels it forward, stays with it.
Echeverria
Now that was some hops, and listen to the ovation here from the Philly fans.
Well, they appreciate a tremendous play, and they just saw one. They saw a spectacular play. It's one thing to leap, but a lot of times you see a guy leap and come down on his feet.